Howdy. Okay. Renewable energy, renewable energy, renewable energy. Something that has been topic of discussion around the globe constantly and constantly and constantly. Al Gore got a Nobel Prize for the slideshow about it. So I guess there's not a lot to talk about what's a renewable energy, but rather speaking about which, in my opinion, would be the most efficient renewable energy. Okay, for a renewable energy to fit into efficiency, I will list some things. First, it must not release or have side effects that may cause problems to the earth. Second, it must be efficient in the way of matter and energy produced. It must be reliable. It means that you are not going to be jeopardizing your energy because there's, for example, not enough wind to power the turbine. So I have already gave you a clue. Wind is not a reliable or well an efficient renewable energy according to my opinion. The most reliable might be just a utopia, but is nuclear energy. Okay, before you say anything, just let me finish. I'm speaking about fusion, not fission. Fission is when we have a. Let's just mind this is a uranium 236 and it will just start decaying, but it will take. I guess it takes like 260 years, something like that. So I will take a smaller electron and shoot it to the core. It will split, releasing 192 eV of energy. This is from the binding energy that keeps everything together inside the nucleus. But the thing is that when it decays, it gets split, it will produce krypton and boron. But these two in an isotope that is highly radioactive. So we get a lot of energy, but we're risking too much, as we could see in Chernobyl and also in Japan. So fission energy has already been taken apart. Even Germany, all the Europe, and USA is starting to shut down the reactors. But this only makes me a bit critical because we see the sun. Okay, the sun is the perfect and well the nearest example of fusion that we have. Fusion is safer. For example, what does fusion is? I will show you what fusion is. Let's just imagine this small USB. It's H3, and I will show you something really cool. This would be deuterium H2. Okay, so what we do is that they will get so fast one at the other. They will be traveling so fast that the magnetic energy that will repel them will be exceeded by their speed, and they will bond. But this can only happen in the sun. For now, there have been really important advances in this field because everybody thinks that it's the future. Well, not everybody, just bragging about what I think. Okay, so the main problem about it is that to get that fusion happening, you need a lot of energy to make them move at that speed and a lot of gravity to make them bond together. This only happens in the sun's core. I'm not speaking about the sun, I'm speaking about the sun, a star, and this energy is what makes the stars shine. Not like diamonds. Diamonds don't shine. they reflect. So sorry, Rihanna, you're wrong. Okay, that's why I think fusion is the best solution for energy issues today. It's safer, it doesn't produce radiation, it takes just so little matter. I mean, uh, with one atom of H2 and one atom of H3, you get a bond energy released of 18 million eV. So it's pretty much, I mean, in large scale, it will be blasting numbers. Okay, so I will be finishing because it's almost the double time I was supposed to speak. Bye.